Have you ever wondered how your smartphone manages to hold a charge for such a long time? Or how your car starts up with just the turn of a key? The answer to these questions lies in a small yet powerful component known as a capacitor. A capacitor, in its simplest form, is an electrical component that stores and releases electrical energy. Imagine a reservoir that collects and holds water until it's needed. That's essentially what a capacitor does, but with electricity instead of water. Capacitors come in all shapes and sizes, but regardless of their physical attributes, they all share the same basic structure. They consist of two conductive surfaces, or plates, separated by a non-conductive material known as a dielectric. When voltage, or electrical pressure, is applied, the plates store electrical charges, positive on one side and negative on the other. This charge separation creates an electric field, a kind of electrical tension that holds the energy until it's needed. This brings us to the concept of capacitance. Capacitance is the measure of a capacitor's ability to store electrical energy. It's like the size of our imaginary reservoir. A larger capacitance means more electrical energy can be stored, and it's usually measured in units called farads, named after the famous scientist Michael Faraday. Understanding capacitors and capacitance isn't just about knowing how your phone or car works. It's about understanding the fundamental principles of how electricity is stored and used. It's about appreciating the invisible forces that power our everyday lives. So what are the key points to remember about capacitors and capacitance? First, a capacitor is an electrical component that stores and releases electrical energy, much like a reservoir stores and releases water. Second, capacitors consist of two conductive plates separated by a non-conductive material, and they store energy by creating an electric field between these plates. Third, capacitance is a measure of a capacitor's ability to store electrical energy. The larger the capacitance, the more energy a capacitor can store. And finally, understanding capacitors and capacitance isn't just about electronics. It's about understanding the fundamental principles that power our world. So the next time you charge your phone or start your car, spare a thought for the humble capacitor. It may be small, but its role in our lives is anything but insignificant.